Hi everyone, let's jump into our fluency then. So we're carrying on with this idea of bridging 10. So we've got two addends that are going to make a number larger than 10, but we are going to partition that second addend into two smaller parts to make 10 first. So I think I've given you enough examples by this point. It might be worth pausing the video and seeing if you can have a go. And then I will go through the answers. Great, hopefully you've had a go by now. Let's have a look at this first one then. So 9 plus 6. Instead of adding 6 all in one go, I am going to look for a number that bonds with 9 to make 10. Remember, we're making 10. It's the make 10 strategy. So I know that 9 plus 1 makes 10, but I didn't want to just add 1. I wanted to add 6. So how many more do I need to add to 1 to make the full 6? So I want to add 6. So far I've added 1. I've got 5 left to add. So now instead of doing 9 plus 6, we can partition our 6 and do 9 plus 1 because that equals 10, and then 10 plus 5 equals 15. Well done if you got that right. If that one was a little bit tricky for you, why don't you have a go at pausing the video now, having a go at the rest, and then playing it again when you're ready. Everyone else who's ready, let's go through the rest of them then. So 8 plus 7, I'm going to partition my 7 into a 2 because 2 bonds with 8 to make 10, and then I've got 5 more left. So 8 plus 2 equals 10, 10 plus 5 equals 15. 7 plus 4, well, 7 plus 3 equals 10. And then I didn't want to just add 3, I wanted to add 4, so I need to add 1 more. So 10 add 1 equals 11. And then 9 plus 5, well, I'm going to partition my 5 into 1 because it bonds with 9 to make 10, but I need to add 4 more to make my full 5. So 10 plus 4 equals 14. Well done if you got those right. Okay, so hopefully we have got a nice quick maths lesson for you today because we've done something very similar with our 2D shapes. So today we're going to bring together all that knowledge of our 3D shapes and use that to try and compare them and sort them into a Venn diagram. So let's go through our success criteria then. 3D shapes have, now there's two ways that we could fill this in. 3D shapes have height, width, and depth, but we could also say that 3D shapes have sides, edges. Let me start that again so I can say it correctly. Well done if you said it right the first time. 3D shapes have faces, edges, and vertices. Now, a face is a flat or a curved side on a 3D shape. An edge is where those faces meet. It can be a straight edge or it can be a curved edge. And a vertex is a point, usually where edges meet, but not always. For example, in a cone. Let's have a look then. So using the sentence frame on the bottom, I would like you to please pause the video and complete that sentence frame for as many of these 3D shapes as you can. Can you tell me their name, the number of faces, the shape of the faces, the number of edges, and the number of vertices? Just do as many as you can, please. Great, hopefully you've had a go at using that sentence frame for as many 3D shapes as you can. Let's go through them. So this is a cylinder because it has 2 circular faces and 1 curved face. So it's got 3 faces altogether. It has got 2 edges and no vertices. This is a cuboid because it has either 6 rectangular faces or potentially 4 rectangular faces and 2 square faces, which is 6 faces altogether. It has 12 edges and 8 vertices. This is a square-based pyramid because it has one square face and 4 triangular faces, which is 5 faces altogether. It has got 8 edges and it has got 5 vertices. This is a sphere because it has one curved face. It has got no edges and no vertices. This is a triangular prism because it has 2 triangular faces and 3 rectangular faces. Altogether, that's 5 faces. It has got 9 edges and it has got 6 vertices. This is a cone because it has one flat circular face on the base and one curved face going around the sides of it. So 2 faces altogether. It has got 1 edge and 1 vertex. This is a cube because it has 6 square faces, 12 edges and 8 vertices. And this is a triangular based pyramid because it has 4 triangular faces. It has got 6 edges and 4 vertices. Well done if you got all of those right. That is a lot of information to keep in your head. Well done if you even just got a few of them right. Okay, so now we've gone through all of that, can we have a think about some of the similarities and some of the differences? What do these shapes have in common and what do they not? Great, so I'll share some of my ideas and maybe you will have said some of the same as mine. So I'm going to say that the cylinder and the cone are similar because they both have a circular face. The cube and the cuboid are similar because they both have the same number of faces, vertices and edges. The triangular base pyramid and the square base pyramid are similar because they both have triangular faces. The sphere and the cylinder and the cone are similar because they all have a curved face. But I could say, for example, that the sphere and the cube, for example, are different because a sphere has a curved face and a cube just has flat faces. I could say that the cylinder and the square base pyramid are different because they have different number of faces and one of them has triangular faces and the other one does not. And there's lots of things that you can say like that where, for example, the cone has a circular face but the triangular prism does not, so that makes them different. Or I could say the cone and the sphere are different because the cone has a vertex and an edge, but the sphere does not. So well done if you said any of those, and well done also if you said anything different that I haven't thought of. So what we're going to do then is we are going to put these into our Venn diagram. So with our Venn diagrams, just like last time, this blue circle represents one category, our red circle represents a different category, and if it is something that falls into both categories, then that would belong in the middle of our Venn diagrams. Now, in terms of the challenges, you can either do the 1-star challenge, which is where those are already filled in for you here. So you can see there, I have chosen the names of those categories for you. This one is has vertices, this one is has square faces. Or if you want that 2-star challenge, you can use the Venn diagram that has the categories blank for you to label. Now, if you're struggling to think of your own names for categories, then I have got a little table here with some ideas in. So for example, looking at that, I'm going to say that this side has flat faces, and I'm gonna name this side, I'll do has curved faces. There we go, has I'll say has a curved face, has a curved face. And I'll do this one as has a flat face. But you can name yours whatever you like, as long as they relate to the properties of 3D shapes. Okay then, so let's go through them then. So our triangular prism, does it have a flat face? Yes, it does. Does it have a curved face? No, it does not, so it belongs here. The square-based pyramid, does it have a flat face? Yes, it does. Does it have a curved face? No, it doesn't. What about our cone? Does the cone have a flat face? Yes, it does. Does it also have a curved face? Yes, it does. So it belongs to both of these categories, so it goes in the middle. Cuboid, does it have a flat face? Yes, it does. It has 6 of them. Does it have any curved faces? No, it does not. So it belongs only in the blue circle. Triangular based pyramid, does it have flat faces? Yes, it does. It has 4 of them. Does it have any curved faces as well? No, it does not. So it only belongs in our blue circle. Cylinder, does it have any flat faces? Yes, it does. It has 2 of them, one on the top and one on the bottom. Does it have any curved faces as well? Well, yes, it does. The one that goes around the middle. So once again, it belongs in both of them. Our sphere. Does our sphere have any flat faces? No, it does not. It only has 1 curved face. So that would mean it belongs only in the red circle. And last but not least, we've got our cube. Does the cube have a flat face? Yes, it does. It has 6 of them. Does it have any curved faces? No, it does not. So it belongs only in the blue circle. So that's how I've organised my Venn diagram. But like I said, we could have done that in many different ways had I just named my Venn diagrams something a little bit different. So that is what you're going to do now. These sheets are available to download on the Byron Wood School website in the home learning section, or you could draw your own Venn diagrams and write the names of the shapes in the right places. There are many ways that you can do this. The sheets that you can download are interactive, which means that you can physically click on the shape and drag it there. Or if you've got a printout version, maybe you want to cut the shapes out and put them where they belong. Now, just a reminder, because there wasn't an example of this within here, if there was a shape that did not fit into any of my categories at all, where do you think it would need to go? That's right, well done if you said it needs to go outside of my circle. So well done everybody. Hopefully that was nice and quick and didn't take up too much of your time, and you can have fun getting on with your maths activity for today. See you tomorrow for another math lesson. Bye everyone.